Okay, so in the last video we showed you how to fold an equilateral triangle from a square sheet of paper by taking the top corners and folding them down to the middle lines. In this video, we're going to show you why that happens mathematically. So, we are going to start off by assigning a side length to the square, and it's going to be 2. I could have assigned it 1, I could have assigned it 9, I could have assigned it a bajillion. The beauty of math is that it will always cancel out in the end. So if this has a side length of 2, it's a square, and this has a side length of 2. And when we fold down this flap, this has a side length of 2 because it's the same edge. We've just moved it onto the sheet of paper. So I'm going to highlight this in blue. The blue line has a side length of 2. If this has a side length of 2, and this is a half of the side length, then we know that from this point down, it has a side length of 1. If that has a side length of 1, and this has a side length of 2, oh my goodness, we realize it's a special triangle. A 30, 60, 90 special triangle. Now, it's really tempting for us to say that we want 30 here. And we could say, well, we see by the Z rule that if we have 30 at this angle, we have 30 at this angle. And we can notice that this is an isosceles triangle and this is 30, so it's 60. But we can't do that because this is math. And we didn't say this is an isosceles triangle. And this is a proof. So we can't do that method. We have to find a new way. So we're going to go a bit differently, a bit of a different roundabout, and I'm going to introduce an extra fold. I'm going to fold it vertically in half. And the reason why I do this is so we can construct another special triangle somewhere else on the page. Where? Well, we know we're going to want to use a 1, so we take it from the vertical point now and create a side length of 1. Now, you may have guessed it since I'm telling you we're going to use a special triangle, but this length here is 2. How can we see that? Well, since it's a square, all side lengths are 2. If I fold this up, this has a side length of 2. If I fold this point here, this also has a side length of 2. It has a side length of 2. So, if we highlight this again in blue, side length of 2, we have another special triangle, which is a 30, 60, 90 triangle. And what's the leftover in this? We know that right angles are 90, and if we have 30 and 30, then this one must also be 30. And since this is the crease we're using, 30 plus 30 is 60, and that's why we get a 60-degree angle there. Same on this side, we get a 60-degree angle, and by leftovers, we get another 60-degree angle, create an equilateral triangle. Now you may have noticed that we have 30, 30, 30 here, which are all the same angles. This is actually a special case of something called trisecting an angle, which is where we take any angle and we break it up into 3 equal parts. The Greek mathematicians couldn't do that. They had no way of trisecting an angle using their traditional compass and ruler technique. Origami is more powerful than that. And we're going to do a video in the future that talks about congruency of triangles. So you still need to know your special triangles in trig, unfortunately for you guys. But what's really cool is that we can show the trisection. So if you're interested in that, look that up in another video. However, for the meanwhile, the challenge question for this video is, we notice that if we take this triangle, it has some room to rotate inside the square. So it's not the maximum area it could be. Our challenge question is, what is the maximum area of a triangle you can get inside a square? It's pretty tricky, but I have faith in you guys that you can do it. And what's really fun is that a lot of the times you hear the word calculus thrown around, And you could use calculus to solve this, but it's actually so much simpler to use a little bit of basic grade 10 trig, and it's more powerful than calculus in this case because it's easier and you can just figure it out. So take that home. It's a really fun challenge. I hope you enjoy it. And if you want to learn how to fold the buckyball from the prior video, we're going to show you how to take a triangular piece of paper and fold it into a piece. So watch the next video if you're interested in that. Now this isn't necessary, but I like to just make it a bit more secure by locking it by flipping this flap underneath, just so it's nice and locked.